that he draws, second column, space does not represent any quality of objects by themselves. Space is nothing but the form of all phenomena of the external senses. It's from the human standpoint only that we can speak of space. If we drop the subjective condition, space means nothing. So on 380, he puts it this way, bottom of the first column. Our discussions teach the reality, the objective validity of space with regards to everything that can come to us externally as an object, but the ideality of space with regards to things considered in themselves by our reason, independent of the senses. Now, what's he saying? Well, he says it again in another way, and this is clearer. We maintain the empirical reality of space as far as every possible external experience is concerned. Yeah, you really experience things spatially. That's the empirical. In experience, it's real to you. In the world as it is for you, experience is spatial. In the world as it is in itself, it's not. You see, the empirical reality. But then he goes on, at the same time, it's transcendental ideality. That is to say, space is nothing if we leave out of consideration possible experiences and accept it as something on which things by themselves are in any way dependent. No, it's nothing. It's simply an ideal that the transcendental mind has in ordering its experience. Now, the same is true almost verbatim with regards to time. And after the discussion of time, he gets to a more general explanation. And on 384, makes his conclusion halfway down the first column. Time and space are two sources of knowledge from which various a priori synthetic cognitions can be derived. Of this, pure mathematics gives us a splendid example. How come? Space, yeah, that's what geometry is about. The science of the idea space. You see, geometry is not about round balls. It's about geometrical objects such as circles and spheres. It's not about any line or triangle I draw on the board. It's about the ideal straight line or triangle. A straight line, in mathematical definition, has length but no breadth. In other words, it doesn't exist empirically. You couldn't see it. You see. A point has location but no dimensions in geometry. A point is not an empirical object. Points and lines and triangles and circles or spheres are ideal entities, thought entities, that don't exist empirically in the physical world. You see. So there can be a science of this transcendental form. What about time? Mathematics of time? Yeah, how about number series? Sequences, number series. Arithmetic is the science of sequence of time. You see. So what then are we going to say about the status of mathematics? Oh, you see, philosophy of mathematics is very much involved here. Plato had a philosophy of mathematics in which mathematical objects were real objective entities. The ideal of equality. equal length. The ideal of triangle, whatever. No objective reality to mathematical objects for Kant. They're concepts. Kant is a conceptualist. Plato was a realist about such things. The nominalist will see them simply as dealing with relations between arbitrary ideas defined arbitrarily. The conceptualist will see mathematics as dealing with abstract ideas, either universal ones or created ones, abstract ideas. The nominalist see it dealing simply with the meanings of words. And to this day, you have those three major traditions in the foundations of mathematics. Kant, very influential. Just last week, I received a copy of a book from one of our graduates, Mick Detlefson, who teaches philosophy of mathematics at Notre Dame. This is his second book. It's in the philosophy of mathematics, and he's dealing with precisely this kind of question. Well, the transcendental aesthetic. A couple of minutes. Questions? Then let's call it a day and come back next time to the analytic.